breaking the wall of heavy metals waste. Upasana Jhariya, Falling Walls Lab, Sendai.
I hope you all are enjoying the refreshing coffee they are serving here. But what if I told you that along with the coffee, you might be consuming heavy metals like arsenic or cadmium? These heavy metals can enter our body in many ways. But the real problem is that once they enter our ecosystem, they don't degrade and causes toxic effects to every living organism. Let's consider the devastating Hinckley disaster in California or Minamata disease in Japan in 1950s. Both led to life-threatening diseases like cancer or neurological disorders. And even decades later, the remediation is still going on. But where do these heavy metals come from? More than 50% heavy metal contamination stems from acid mine drainage. In US, 40 abundant mine alone produces around 25 billion gallons of mine drainage. And this amount is enough to satisfy half of the Europe's daily needs. This issue is so severe that United Nations declared mine drainage as the second largest environmental problem on the earth. Conventional solutions are not suitable because they either produce secondary hazardous waste or fails at high concentration. So, how do we find a solution that's not only effective, but also cheap, sustainable, and scalable? Turns out that another major component of mine drainage is iron, and that's the key to my research. I'm developing a sustainable hybrid solution by using naturally occurring iron oxidizing bacteria. These bacteria utilizes iron present in mine drainage and produces iron nanoparticles. These iron nanoparticles are incredibly effective at absorbing heavy metals from mine waste as well as industrial wastewater and making it free of wastewater. We have obtained some remarkable results at lab scale and now testing at industrial level. But the story doesn't end here. The adsorbed heavy metals can be collected and upcycled for economic purposes, turning waste into wealth. After adsorption, these nanoparticles can be regenerated and reused, making the process extra cheaper. Simultaneously, these nanoparticles can remove other water contaminants like fluorides, thereby increasing the sustainability. Therefore, by using these iron nanoparticles with their high adsorption capacity, good separation ability, and excellent reusability, I'm targeting a sustainable solution to break the wall of heavy metals waste, so us and our future generation can take heavy metals very lightly. Thank you.